Uh, Sir, can I ask something?
Yes, yes, please.
Right now, I think there are only three persons in this meeting. That's why I want to ask. I want to ask. I want to know actually only the faculties are present in this particular presentation, or student will also join.
No, sir. Actually, there are different seminar halls in the university campus, and
Okay, sir.
through projector, like cinema hall,
Mm-hmm.
a student and faculty members are there.
Okay, means students will also present over there.
Yes, yes,
Okay,
yes.
and those students are from only from EE department and electronics
No, no,
department,
no,
or
no. Multidisciplinary. For
okay, all
all.
multidisciplinary. Okay, okay. Because my topic is as Sarika ma'am told me to choose this particular topic, that power converters, and power converters, as you know, sir, it is a hardcore topic of electrical
No, no.
engineering.
So you should, make it practical because this is a training session, right?
Yes, yes, of course. I will at the end of my session, I will show MATLAB Simulink model, as well as I will run that model and show the result in my on my particular laptop, so that students can understand how to simulate a particular circuit in a MATLAB and how to get the result. I will show
Yes, sir.
in my MATLAB platform.
Just wait for only 2 and 3 minutes. Only just please.
Okay, okay, sir. Okay, okay.
Yes. So, Somnath Banerjee, sir, please. So, on behalf of Jyoti Vidyapeeth Women's University, as well as our partner institute, Asoka Institute of Technology and Management, Varanasi, we, the organizing team of this multidisciplinary skill development workshop, we welcome you and our students, our scholars, our faculty members, and other stakeholders all are very excited to listen you because you are going to, sort out or you are going to train some techniques for those who are not very in the, in practical position to do something by using power converter or by the application of simulation and modeling. So let me introduce firstly Somendra Banerjee sir is the HOD in the Department of Electrical Engineering in Asoka Institute of Technology and Management, and he is the resource person who is going to, give some tips to all the participants to train themselves for the practical purposes. The term power is very very common to you for everyone, whatever may be the subject, whatever may be the discipline. Converter, you are also well known to the fact, but the nowadays simulation and modeling, I hope that everyone is known to the aspect of electrical vehicles and other industrial growth, other transformational projects and dealings related to the industry outcomes based on the technological based outcomes. So मैं ज़्यादा बहस करके बिना I would like to request our expert of the session and the resource person, Professor Somnath Banerjee sir. Over to you, please.
Thank you, sir. Thank you very much. Am I audible?
Yes, yes, sir.
Okay. Okay. Good afternoon, one and all present over here. Myself, Somen Banerjee, as sir has give my introduction in a very well mannered, so I need not to say anything about myself actually. And but a little introduction I want to give about myself. That's I'm Somen Banerjee. I've completed my MTech from NITTTR Chandigarh, and right now I'm pursuing PhD from Triple MUT Gorakhpur. And I have 14 years of teaching experience and 6 months of industrial experience also. Um, and right now I'm working as an assistant professor and head of the department in electrical engineering in Ashoka Institute of Technology and Management. And I want to start without wasting any time. I want to start my presentation. For that, I request the organizing team to please let me share my screen. Actually, I can I
Yes, yes, sir. Yes, please, sir. Please.
okay, 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 sir. Is my screen is visible to all?
Yes, yes.
Okay,
It is.
thank you, sir. Thank you. Okay, this is a multidisciplinary skill development workshop, and in this session, I will going to represent about the power electronics converter, their application, and model MATLAB Simulink model. Uh, in this particular session, I will going to talk about the introduction of power converter, classification, its application, advantage, challenges, and different type of power converters. Then at last I will discuss about the Simulink model of power converter and result in the Simulink model. And at the end of the session, I will show how to simulate a particular circuit in MATLAB, a power converter circuit in MATLAB, and I will show the result also. Uh, so let's start. What is power converter? First, uh, before knowing about the simulation, before knowing about the different type of power converter, first we have to know the power converter, what is power converter and what is the significance of power converter. Look, electrical engineering is one of the important topic, or one of the important branch of engineering, because everyone required electrical energy for their survival. Each and every country required electrical energy for their survival. So need to we need to convert the electrical energy, the electrical power, in one form to another form, or in um, one phase to another phase, in such a way that we can use as per our requirement. For example, before dealing with all the power converters, I want to discuss about the significance of the power converters. So let me allow to discuss about the significance.
This slide is blank.
Yes, 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 of course. I'm going, look, suppose this is a plant. Now what is plant? Any system which fulfill our requirement, which fulfill our desired output, is considered as a plant. Like a motor, we use motor in our day to life in everywhere. We use motor in our fan, we use motor in our washing machine, we use motor in our different type of compressor and different type of condenser. We use motor everywhere, in industry, in lift system, in our building, in accelerators, where everywhere we are using a motor. But motor with the supply, with its supply, is nothing for us. If we want to use the motor, then we have to take out a desired output from that motor. And to take out the desired output from that motor, we have to control that motor. So to control that motor, we required a particular circuit which is considered as an actuator circuit. Actuator circuit will control the motor and force the motor to give us our desired output. How this actuator circuit control this motor? Actually, actuator circuit will control this motor from the signal, on the basis of the signal which it get from the controller. This is the controller. So a plant or a motor which, from which we want a desired output, will get the supply from the power source through this actuator, get the power supply through this actuator, and on the basis of the output, actually output of that motor, that plant, will measured by the measuring system. Measuring system will measure the output and feedback that output to controller. Controller always knows what do you want from the motor, because we already to put our desired output in the controller in form of reference. Controller compare the output of the plant with the reference, and on the basis of that it will send the signal to the actuator, and on the basis of the controller output signal, actuator try to control the motor and take out the desired output from the motor. Now in the early age, actually this particular controlling is somewhat very difficult for us. But after the invention of power converters, after the invention of power electronics devices, this particular controlling is become very simple for us, and we are using power electronics converters and power electronic circuit everywhere with the motor, to control the motor or to control anything. See, I'm talking about this particular actuator circuit actually. The power converter circuit, which we going to discuss about, that power converter circuit. That power converter circuit is actually the role of actuator. We are controlling this. These all power converter circuit are based on the power semiconductor devices actually. Semiconductor devices, the silicon and germanium, which we know for which we know very well actually. So this power converter circuit, which is all based on the power semiconductor devices, is fulfill our requirement to control the plant uh, according to the signal sent by the controller. So from this I can say it is very, from this I can say power, this particular power converter is very much important for us if we want to get if we want to take a desired output from any type of plant. I was talking about the motor because motor is also a form of plant, which I have told earlier. But that particular plant can be anything, any type of. It can be motor, it can be solar panel, it can be electric vehicle. In fact, in electric vehicle also we are using motors. So we need to use motor everywhere, which I have already told. So power converter is nothing but it converts the power as per the requirement of the motor. Here I told you ki actuator will give you the actuator will one second. Actuator will control the plant according to the signal coming from the controller. What, how it can control the plant? Actually, when controller send the signal to this power converter circuit, this actuator circuit, it will convert the power coming from source to the in the form of power which required by the plant. For example, if the supply is giving only AC, alternating current, and the plant is a DC motor, and we need to control a DC motor, then in that case, that particular motor required a DC input. It is obvious because it is a DC motor. It required a DC power to perform its rotate to perform its task actually. So the power which is coming from the source in form of AC, that actuator circuit, that power converter circuit, convert that power into the form, in that form which is actually required for the plant. So this particular circuit, as this particular circuit is converting the power from one form to another form, that's why it is known as a power converter. And this is the block diagram of a power converter. I'm showing here the block diagram because there are many types of power converter circuits. So it is not possible to show each and every circuit in a particular diagram. That's why I'm showing it through the block diagram. Here, according to the controlling signal, the input is flowing from source to another source, which can be the load. This particular green, so I'm sorry, this particular green source, if we consider this particular green block as a source, then this red block is load for this particular source. Similarly, if we consider this particular red block as a source, then obviously this green block is load for the source. This shows that power converter transfer the power from one end to another in both the direction. It can move the power, it can um, convert the power for both the circuits. Maybe uh, anyone can ask if this is source, how can this can be also a source? Yes, it is possible, because if this is the source, and if suppose this red block is battery in an electric vehicle or in a grid system, then in that case, when we charge the battery, in that case this green block is source and that battery will become the load. And during the overcharging, when this particular battery discharge, in that case this particular red block is considered as a source and this particular green block considered as a load, because when the battery discharge through this power converter, this power is converted and again give back to that particular source which actually charges that battery. That's why I'm showing source in both the side. A motor can also be behave like a source during the braking of the motor, braking system of the braking topology of the motor. When we apply a brake, if we apply, till now we are using, in when we are using a motor in an industry, we apply the brake through the mechanical system. But nowadays we are using a electrical braking system in which we absorb the power giving to that motor, the kinetic energy which we have already given to the motor, absorb that particular kinetic energy and force the motor to come in the standstill condition. This electrical braking system is actually far better than the mechanical braking system, because it will it will definitely bring the motor in a standstill condition within a microsecond, within a millisecond. First thing, and second thing, there will no, we don't get any power losses in form of friction in electrical braking system. So during the braking of the system, electrical motor, in that case, during the braking topology, that motor is considered as a source. So power converter can convert the power from one form to another form, and it is bidirectional also. Okay. Now, classification of power converters. As per the requirement which I've told earlier, if the plant is DC motor and if the power is AC, then in that case, this particular power converter circuit, this actuator circuit should be such type of circuit which can convert the AC into DC. Similarly, the reverse can also be possible, that the power supply is DC and the plant is AC motor. In that case, that converter need to convert the DC into AC. So as per the requirement, we have to use the power converter circuit as an actuator circuit. So that's why power converter itself classified into different categories. There are few power converter circuit which can convert AC into AC. There are some power converter which can convert DC into DC. There are some power converter circuit which can convert AC into DC, and there are some power converter circuit which can convert DC into AC. And which power converter circuit we have to apply in a particular system, that will totally depend upon our requirement. That will totally depend upon the which type of plant we are going to control and which type of supply we are getting from the source. On the basis of that, we have to decide our power converter circuit. Now, when we talking about the AC to AC converter, first of all, it click in the mind, what do you mean by AC to AC converter? If a particular power source is already giving us AC supply, and if the plant is also required of AC supply, then what is the why we need to convert AC into AC, and what is actually the AC to AC conversion means? For that, I want to say only one thing. If the suppose a power supply which we are getting is 230 volt 50 hertz AC. Here 230 volt means I'm talking about the RMS value of the AC voltage. 230 volt 50 hertz AC. But the power required by the plant is 150 volt 50 hertz AC. That means the requirement of the plant, the requirement of the motor is 150 volt RMS value. But the supply, the source is giving us 230 volt. So we require to change that amplitude of the source of the supply from 230 volt to 150 volt. That we can do with the help of power converter circuit. And as this power converter circuit is converting a particular RMS value and a particular frequency of AC into another RMS value and another RMS or another frequency of AC, that's why it is considered as a AC to AC converted power electronic circuit or power converter circuit. In this, we are converting AC into AC, but the AC of particular RMS value, particular magnitude, particular frequency is going to be converted into AC of another magnitude, other frequency. That's why it is considered as AC to AC converter. Similarly, for the DC to DC converter, we know DC is direct current. It's a constant actually, and its frequency is zero. Okay, that's good. But in case of DC to DC conversion also, suppose the supply is coming from the solar panel. Okay, solar panel will give us a DC supply, and the motor we are using is a DC motor. So, but the problem is that the amplitude of the magnitude of the DC coming from the solar panel is at X value, and the magnitude required by the DC motor is should be at Y value. So we have to convert that X value of magnitude into Y value of magnitude. That will be done by the DC to DC converter actually. And if I'm talking about the AC to DC converter, it's simple that we are converting the AC into DC. Similarly, if we are talking about the DC to AC converter, in that case we are converting DC into AC, and we are using this particular converter in our home nowadays. This is very popular because I think everyone in every household we are using inverter. The common name of DC to AC converter is inverter. It's converting the DC or the battery in particular magnitude of AC at a particular frequency of AC, which we use in our houses to run different type of appliances. Now, this AC to AC converter, the DC to DC converter, AC to DC converter, this DC to AC converter, they have lots of their sub branches also, different forms actually. For example, if we're talking about the AC to DC converter, if I'm talking about the AC to DC converter, in that case, we can convert the single phase AC into DC. We can convert the three phase AC into DC. We can convert the single phase AC into half value of DC, which is considered as a half wave rectifier or half wave converter. When we are using a single phase and converting the full single phase magnitude into DC, in that case, it's considered as a single phase full wave converter. When we are converting the three phase into DC power, in that case also there are two types of power converter circuits: half wave converter and full wave converter. So these particular converters again subcategorize into different form in different converters, and all the convert forms are very important for us, and they are used in different topologies as per our requirement. In nowadays actually, DC to DC converter is very much very important actually for us. We are always talking about the DC to DC converter because the use of DC to DC converter in electric vehicle and in power grid, smart grid actually. When we are talking about the smart grid or a micro grid, in those grid system, actually we are using the non-renewable resources, renewable resources, non-conventional resources actually, renewable resources into our required value, required power supply value. So first of all, we need to convert that solar energy, the renewable energy, so the voltage or current we are getting from the renewable sources into a particular value, and then we have to convert that particular value into AC. Similarly, in case of electric vehicle also, in case of electric vehicle also, we need to convert the DC power into DC power, because most of the case in nowadays in electric vehicles we are using a different type of DC motors to run the particular vehicle. So due to the use in a large extent of this DC to DC converter in grid system and electric vehicle system, this buck converter, this boost converter, buck boost converter, they are very much familiar for us. Now I'm going to discuss all these things one by one, all the converter in detail one by one, before going towards the simulation of this converter. Before discussing about this particular converter, I want to discuss about their applications, because after knowing about these applications, after knowing about the challenges, advantages of this particular power converter device, I think it is more suitable for us to understand the things clearly. So I've already discussed some applications. Here I'm going to repeat those applications, and I'm going to add some more application about the power converter. First application of power converter is renewable energy integration. So here we can see, which I have told earlier, we are using the renewable sources in a grid system. And when we are talking about the renewable sources, especially in our country, there are two renewable sources which we can use in a large extent, that is solar energy and wind energy. If we are talking about the solar energy, we have to convert the solar energy into electrical power. We do require a photovoltaic cell, and when we are using the photovoltaic cell, in that case, that we are getting the power in form of DC. Now when we are getting the power in form of DC, we have to convert that power into AC as per our requirement, or we can have to change the magnitude of that DC and convert that DC into another form of DC, in convert that fixed DC into adjustable DC actually, as per the requirement. So we are using this power electronics converter in solar panel, wind and wind turbine in many places to integrate this renewable energy with our grid system. Then next important use of power converters is electric transportation, that is electric vehicle. In case of electric vehicle also, we required to convert the power from one form to another form, and to convert the power we required power converters. Then except this particular grid system application and electric vehicle, there are many more application for the power electronics devices like laptop, smartphone, televisions. Everywhere everywhere we are using these power converters. In fact, if we want to see, we can open up our that washing machine in our house, the panel of the washing machine in our house, and we can see the different power converter circuit in that particular washing machine also. And definitely the commercial use and the commercial use and with the domestic use, there is a large extent of industrial use of this particular power semiconductor circuit, because semiconductor concept come into the existence from the industrial use, on means as per the requirement of industries, as per the requirement of power conversion in industry, we have invented actually this particular power semiconductor devices. Now we are using the power converter for the energy storage also, that is for storing the energy in the battery, which I have talked earlier also. Suppose we have a battery, as a load, we have to charge that battery from a particular source, and when we require that energy which we have charged, which we have stored in that battery considered as a low source, and that battery gives supply to the particular plant. So we need to store the energy in the battery for our emergency conditions. For example, if in case of power cut in our households, in our houses, we are using the inverter circuit. But inverter is a circuit which only convert the DC into AC. From where that DC power is, that inverter circuit is getting that DC power? From the battery. During the power supply which we are getting from the substation, we are charging that battery. We are getting the power in our houses through that particular inverter circuit, and that inverter circuit in parallelly charging the battery also for the emergency condition. And during the power cut, that battery energy of that battery is used by us to run our home appliances. So we have to store the energy in the battery. But for controlling the current, for controlling the current of charging current, actually we required a power converter to charge the battery. Because if we are not using any power converter to charging a battery, and if we are try to charge a battery through a particular source directly, in that case, with due to any fault, type of fault, if the current will increase, if the voltage will increase, that increment of the voltage or current, or if the voltage or current is in normal condition also, if there is suppose there is nothing like any type of fault, but the supply is giving the particular power and voltage and current which is not matching with the voltage and current required by the battery, in that case there will be overheating of the battery. The battery can be overheated, and which decrease the life of the lifespan of the battery. So to avoid this overheating, we need to give the battery such amplitude of voltage and current which is actually required by the battery, and that can be only happen when we put a power converter circuit in between the supply and the battery. That's why we are using the power converter circuit in the energy storage elements also. Lighting and lighting control, yes, we are using different type of lights in our houses, in our particular uh, industries also, and there we are using, suppose now anyone can ask me what is the requirement of power converter in lighting, why we need to control the lighting. Yes, we can switch on the light when we required, when we can switch off the light when we do not required. But what will happen if we forgot to switch off the light? In that case, if we're putting a particular converter circuit which which has a controller, and according to the programming which we have put in the controller, if that particular controller is doing that job for me, then what is the disadvantage in that? We can control the light, we don't require any person. If even we don't if we forgot to switch off or switch on the light, that will that will perform, that particular task will be performed by the controller and the power converter circuit in place of particular person. So we are using this controlling system in lightning also. This is the also a very important use of power distribution, of power converter circuit, the power distribution and transmission. The elect persons in this particular this particular seminar, in this particular presentation, the persons they who are related with the electrical engineering, they know about the importance of distribution and transmission. The power which we are using in our society, we are getting this power by converting one form of energy into an electrical energy somewhere very far from us. Then we have to transmit that energy from that place, and we have to take that energy, that power, into a particular place from where we can distribute that power to different in the industry, different malls, different commercial places, in different households also. So this transmission and distribution have to be managed in a, this is a very huge network actually, and we have to manage that particular network. For that, we required the power converter circuit to to control that particular network so that we can distribute and transmit the energy as per the requirement. And then medical equipments. In today's life, all the medical equipments are using different type of sensors and different type of transducers, and uh, they are getting the power from the different type of supplies, and to get the power from different type of supplies, we require the power semiconductor devices so that we can convert the power in such a value which required by the medical equipments. These are the different applications of power converters. Actually, I'm just considering these applications as an example. There are many lot different other applications also. We have, so I think we have shortage of time, so we can't discuss each and every application in details. That's why I'm taking
No
just.
issue, no issue, no issue, Professor
Okay.
Banerjee. Please,
Okay,
please.
thank you, sir. Thank you. Thank you. Now the advantage. We till now we have discussed about the applications. I'm continuously talking about the power converter. We are using power converter here, and we are using power converter there, and different places. But why we are using power converter? Why we are using power? This power electronic circuits. Look, all the electronic circuits which we are using, I'm talking about the conventional electronic circuits. They are based on the semiconductor devices. The semiconductor is one of the most important and integrated part of our life actually. And in previous time, we are using these semiconductor devices for the electronics equipments only. And we got a very tremendous and very huge improvement in electronic circuits and controlling of the electronic circuit just because of these semiconductor devices. So our engineers and our researchers also thought that if we can use the semiconductor devices in electronics, when I'm talking about the electronic circuits, that means I'm talking about those circuits which which we are using with low level of voltage and low level of current. So when we are using the semiconductor devices for low level of voltage and low level of voltage, then in that case, our researchers thought about if can we use this particular semiconductor device for the high power also. Then after the different research, after the different laboratory work, they found the way that yes, we can use this semiconductor device for the high power also. And the most advantage, the biggest advantage of this using this semiconductor device in high power is that efficiency. We can get a very huge amount of efficiency, more than 85%, more than 90% of efficiency in our system using due to use of these semiconductor devices. As well as these semiconductor devices, use of these semiconductor devices also increase the reliability of the system. It can improve the control, and it gives safety also. So these are the advantage, and obviously these are the cost saving also. When we are using the semiconductor devices, actually, in case of high power, before the power semiconductor devices, we are using the thyraton tube. The thyraton tube are very sluggish, they are very bulky, and they are very costly also. They were very costly. And when we have discovered that thyristor, that's IGBT, that power MOSFET, after the discovering of those particular devices, and when we are using those devices for our rectification, we have replaced, straightforward replaced the thyroton tube with that particular semiconductor devices, because they are much more cost saver, saving equipment as compared to thyroton tube, and they are versatile also. These are the advantage. They are compact, high speed switching. There are lots of advantage of the uh, power converter circuits. But with the advantage, there are some challenges also. I'm not talking about the disadvantage. I'm talking about the challenges. Okay, because if anything which we invent and try to implement in our day-to-day life, we have to face some challenges. But if those devices are very much advantageous for us, in that case, we have to overcome those challenges. And to overcome those challenges, we should know about those challenges first. The first type of challenge which we have to face for using the power converter is thermal management. As we are using these semiconductor devices for high power, there will be definitely huge amount of increment of temperature, and we have to overcome that particular increment of temperature by our thermal management system. And one of the example of the thermal management system is that thermal plates which we are using. If you take a screwdriver and open up your particular inverter box in your house, you can see the MOSFET we are using in the inverter. We are putting those MOSFET in between the some type of plate. It's a plate just like a aluminum plate, and there are some different selfers also, and we put that in MOSFET in that plate. Those plates.
Sorry, sorry, Dr. Banerjee, I would like
Yeah.
to interrupt here. Please, in very few words, please explain MOSFET to the listeners. MOSFET.
Okay, sir. Okay, MOSFET is actually a particular type of power semiconductor device. One sec, please. They'll, one sec, one sec, please. Look, there are different type of power electronics devices, and MOSFET is one of the device which we were using in the particular. Uh, one sec, please. Sorry,
No, no, no issue, sir. Please,
there
please.
is a call from my college, from my faculty members. So can I
Yes,
put?
yes, you entertain
Okay,
them.
okay, okay. Thank you, sir. Thank you very much.
Just a minute, everyone, please wait. Our resource person is on a call, urgent call.
Okay, I'm sorry for the interruption actually. One, we are talking about the MOSFET, right? Look, this is the first of all, this is a symbol of a MOSFET. I'm talking. I can first. I should talking about the symbol. This is a symbol of a MOSFET. MOSFET is a semiconductor device which is voltage driven circuit. Now, what do you mean by voltage driven circuit? If we are talking about the structure of the MOSFET, a basic structure of the MOSFET, from there we can, I think that things will become more clear. One sec. This is the basic structure of the MOSFET. When we are talking about the semiconductor device, to use those semiconductor device in different application, we are using two types of semiconductor device, whether it is silicon or whether it is germanium. We are converting that pure semiconductor device into impure semiconductor device, p type and n type. The p type semiconductor device are those type of semiconductor device in which we are putting some impurities and convert that device in such a particular manner. We are converting that device in a such a particular type in which holes, because when we are talking about the semiconductor, look, semiconductor device is a fourth group element actually. In a periodic table in chemistry, we can see the semiconductor device in the fourth group, in the fourth group. And if the particular element is related with the fourth group, that means it has four valence electron. So that's why this device is in such a way, it's not fully comes in the category of converter, not in the comes in the category of insulator, because conductors has only one or two electrons or three electrons in their valence shell. They can easily share they can easily take out that electron, make those electrons free to get their stability. Similarly, insulator required electrons. They take the electrons and just fix those electrons in their valence shell to get the stability. So we are not getting any free electrons in case of in case of insulator. We are getting lots of very easily we are getting the free electrons in case of conductors. But in case of semiconductors, these particular elements are considered as a semiconductor because there is a small energy gap between their conduction band and the valence band. This energy gap is actually almost zero, or we can say in fact it is zero in case of conductor. This valence band and conduction band overlap with each other. And in case of insulator, this energy gap is very high. But in case of semiconductor, there is such an energy gap in which the electrons can go from valence band to conduction band with at a normal room temperature also. When those electrons are moving towards their conduction band, that they create a holes in their in their previous existing place. Those holes are moving in the opposite direction of the movement of the electrons. So as there are four electrons and four places where the electrons can put where there is no any electrons, That's why the number of holes and number of electrons are just somewhat uh, equal in amount. That's why in case of semiconductor we are giving the credit to the holes also for the movement of the charge carrier, for the movement of, for conduction of the current also. So in case of semiconductor, in case of p type material there are more number of holes, and in case of n type semiconductor material there are more number of electrons. Means the charge, the current carrying carriers are electrons. Majority is electron in n type, and majority is holes in case of p type. So all the semiconductor devices which are we are using is based on n type and p type of semiconductor device, in case whether we are using silicon or mainly we are using silicon actually. So in case of MOSFET, we are just constructing this particular device using a p-type substrate and diffusing an n-type substrate in that particular p-type substrate. Here we are putting two, just a moment, this is a source, this is a gate terminal, and this is a load actually.
Sir,
Okay,
what are the channel in a MOSFET?
what's a,
What are the channel in a MOSFET?
that is p channel and n channel. That's I'm talking about the channel also, sir. I'm going to talking about the channels also. This is a silicon oxide layer actually. Now when it is a simple structure of the MOSFET. Okay, when we are putting the load and the main source in between the source and the drain, in between the source and the drain. Okay, when the current is start flowing from drain to source, it is easy for them to come up to this particular n channel, this particular n channel. But the flowing of current from this n channel to this n channel is somewhat difficult due to this p substrate. This p substrate carrying the holes as a majority carriers. The electrons is are minority carriers in particular this p substrate. So the flowing of current between this n channel and this n channel is somewhat difficult. But when we put this particular voltage source between this source and gate, in that case, when we applying this voltage, this particular silicon dioxide putting some ions in particular near this gate terminal, negative ions and positive ions. Why negative? That this silicon dioxide putting this negative ions near this gate terminal, that is above the positive ions, because of this polarity of this battery. We are connecting the gate terminal with the positive end of the battery. That positive end attracts the negative ions, and as the negative ion attracts toward the positive, definitely this positive ions goes just in the opposite direction. But when this positive ions comes in this particular opposite phase, it will attract all the minority electron towards itself between this n channel. This n channel is like this negative positive ions are accumulated at this place, and this p minority carriers from the p substrate is accumulated, these electrons are accumulated between this n plus channel. Here I'm using the word n plus. This n plus means high doping level. In case of power semiconductor, we are considering N minus P minus, N and P, N plus and P plus. This minus is indicating the low doping level. This is somewhat medium doping level, and this plus is very high doping level. So this N, this both these N channels are very high, at a very high doping level side, and due to the high doping level, they have lots of electrons. But the problem of flowing of current between these N channels is this particular P substrate. And now, after putting this voltage between source and gate, as we creating a channel of electrons between this and substrate, now the current can flow very easily from N to N.
Very nice, Banerjee sir, very nice, very nice. And we are requesting for simulation part of your this aspect.
Yes, of course, sir.
MOSFET is clear. I hope it is clear for all the participants,
Okay.
viewers.
Okay, I'm just there. I'm sorry. There before
No,
the during the
no,
explanation,
you
I'm
are
not seeing the.
you are in a flow. So during flow, for a successful teacher, for a good teacher, he doesn't understand what is the time bound and what is that.
Yeah. Of course, sir. Okay, this is AC to AC converter. AC to DC converter actually. This is the practical AC to DC converter circuit. I'm already talking about all these things. This is actually DC to DC. This is a buck type DC to DC converter. Buck type means actually the DC to DC converters are of two types: buck type and bush type. Buck in which in buck type DC to DC converter, the input voltage has more. The magnitude of the input voltage is more as compared to the output voltage, and in bush type, the magnitude of the output voltage is more than the magnitude of input voltage. That's why they are considered just like a transformer. So that's why DC to DC converter is considered as a DC transformer also. Some persons can consider that as a DC to DC transformer. This is the circuit. This is the buck boost converter which we are using in our electric vehicle, and in case of micro, there here I am showing the PV array also. Now from DC to DC converter, I'm moving towards the DC to AC converter. This is a single phase inverter circuit. Okay, where we are putting four IGBTs. IGBT is also just like a MOSFET, it is also a semiconductor device, four IGBT here between the source and load, and this is a bridge type of circuit. Now, for AC to AC converter, there are two types of AC to AC converters: voltage controller circuit and the cycloconverter circuit. Voltage controller circuit, we can see the voltage controller circuit in our today's fan regulator. In the previous days, the fan regulator are huge in size, but now these fan regulators are very compact actually, because they are the voltage controller circuit. They are just controlling the magnitude of the input voltage of the fan motor by using this particular type of configuration. Here we are using two thyristor. In place of two thyristor, we can use a single track also. Because the track is a bidirectional thyristor, it can um, it can allow the flow of current in both the direction. So we don't require two thyristors in that case. And in fact, in our today's fan regulator, we are using those particular tracks actually. Cycloconverter is also AC to AC converter, which are converting one particular AC of particular frequency into another frequency. There are different type of cycloconverter: single phase to single phase, three phase to three phase, three phase to single phase. Now this is a Simulink model of some power converter. First up, I want to show the Simulink model of buck converter. The buck converter circuit, which I have which I have showed earlier. This particular simulation model is based on this particular circuit diagram. Here we are putting a particular MOSFET. This is drain, source, and gate. We can see Okay, there is a diode and there is a particular okay, DC to DC converter, that is buck converter and boost converter, are also considered as a chopper. But there is a very basic difference between a chopper circuit and a converter circuit, DC to DC converter circuit. A chopper circuit is just converting a DC, one form of DC into a fixed form of DC into adjustable DC. But when it convert the one one form of DC into adjustable DC, in that case, there are lots of ripple also comes in the output of the voltage. To remove those ripples and to get the pure DC from that chopper circuit, we have to use a particular filter circuit here in just between the chopper circuit and the load. And chopper circuit, including that filter, is considered as a DC to DC converter because it's give the pure DC output to the load, pure DC input to the load from the chopper circuit. This particular circuit, output of this particular circuit is containing less amount of ripples, actually harmonics actually. This is the buck convert simulation result actually. This is a boost converter circuit, this is a buck boost converter circuit, this is the inverter circuit. Now I want, as I told earlier, I want to show a particular MATLAB programming. If sir allow me to
Yes, yes, sir,
5 minutes more. Okay,
yes,
sir,
yes.
thank you. This is MATLAB actually. It will take some time to
Yes, in
start.
configuration, it takes time.
Yeah, yes, sir. Yes, sir. Between that, if anyone asks to ask any
If anyone
want to
has
ask any
any,
question, then they can ask. If
no,
anyone want to ask any question.
no issue, sir, no issue. You continue, please.
Okay, sir. Okay, for sir, for few time I want to stop my sharing so that I can open
Yes,
up my
yes, yes,
MATLAB and
yes, please,
okay, okay,
please.
okay, okay, sir.
I hope, Banerjee, sir, your this MATLAB will take more timing.
No, sir, it's opening actually. Oh, okay, sir. It's visible. Actually, sir, it's a 2013 version, and it is somewhat some means it is heavy software actually. Na? You know
Yeah, yeah,
about
definitely.
it, that's why.
You are supposed to configure in your system firstly, then it works.
Yes, yes, sir. Now it's the window, MATLAB window has been open. So for only few seconds I required, sir. Okay, sir. Actually, I've for my presentation for particularly this workshop lecture, I have yesterday I've simulated two different circuit. One is single phase half wave rectifier circuit, and one is solar tracker circuit in the
Yes, you
simulation.
explain just
Yeah,
in
yeah,
this manner. There is no need to
yes, yes, yes.
show. Sir, please.
Yeah, of course, sir. Uh, oh, actually, I think I should keep it up open before starting of class, but I can't understand with that it will take such a time. Yeah, this is the
Thank you
half
for
wave
your
rectifier.
passion. Thank
Okay,
you
thank
for
you,
your
sir.
passion. Thank you.
This is the thank you, sir, for thank. I want to thanks all of you for your keeping patience.
No, no.
Okay, okay. This is a single phase half wave rectifier circuit which I have simulated. Actually, due to the lack of timing, I'm not able to create any particular complicated circuit. That's why to show all of you, I have created this simple circuit of single phase half wave rectifier in which I am using a thyristor SCR actually to feed the from AC source to particular RL RL load actually. And if if anyone want to ask about these blocks, then they can free to ask. This is the method of showing the this actually creating a block diagram circuit in a MATLAB. Now I'm going to run this particular circuit and I want to show the output of the scope which I'm getting. Look in scope, I have created a two channel scope in where in first channel I'm just putting this input I'm measuring this input voltage and just putting in the channel 1, and I'm putting the voltage across the load in channel 2. Now this is the output. One sec. See, from here to here, this is between we can consider it as a pi angle. For pi angle, I'm just we are just getting the output in this way, and after pi just we are using a inductor RL load. That's why I'm getting this particular portion in the negative side of the input. This is considered as a latching of the thyristor just because of the inductor. Because if we are using the resistive load, in that case, when this input voltage is going to from zero pi from positive to negative, when this input voltage is going to from positive half to negative half, immediately that thyristor will switch off due to reversal of the voltage, and it will not conduct, and we are getting the zero voltage for the whole negative half portion of the input. But here we are getting some voltage just because of the inductor, because inductor opposes the change of current, immediate change of current. That's why the energy which inductor is stored during the supply of power from source to load, inductor use that energy to keeping the thyristor in the on condition, and that's why when the thyristor keeps on for particular for a very few small time span, in that time span we are getting this particular voltage in the negative half also. And when this negative up to where we are getting this negative portion of the voltage, that will depend upon the value of the inductor. As the inductor value is very high, the it will store more energy, it will continue to discharge, that is giving up energy in the circuit for long duration, and for that long portion, in that case for long portion of time, we are the our thyristor will remain in the on condition. So the this latching portion is actually depend upon the value of the inductor of this RL load. This is the one circuit which I want to show now. This is the another circuit which I have simulated. This is one sec. This is a solar tracker. Means how our controller is just changing the direction, changing the angle of the PV cell as per the change of the direction of the sun. Here I am simulating here that particular circuit here. Look, just when the position the change of position of the sun is constant, it will not variable actually. So I'm giving this a constant input, and from here how the theta angle of the solar panel is changing with respect to the change of the position here. That's I want to show. These are the two circuits which I've uh, simulated yesterday. And here I'm using a PI controller. Here I'm using a PI controller to control the motor. We can use the PID controller also. So if we are going to use a PID controller, this particular lagging, the um, look there, the change of angle is starting from uh, approaches towards the desired value with some delay. This delay will decrease when we are using PID controller actually. This is all about the simulation and power converter. Thank you very much to all of you for listening me with such a patience. And if anyone want to ask anything, then they are free to ask.
Thank
And
you,
thank you,
Dr.
sir.
Banerjee sir. And really, it was very, very informative, very, very practical based learning for all the participants of this workshop. And we are thankful for
Thank you,
your
sir.
such a very the exhaustive presentation. And since we were also interested to listen something about MOSFET in between your presentation, so we dare to,
Yes,
place
sir.
that so that we can listen, because it was a cause of, curiosity by our side also, that what
Definitely,
is
sir. Definitely.
and how this, how this MOSFET plays important role during converter. And the at the end of the session, the things that is very, very complicated, as according to the learners, MATLAB, you know.
Mhm.
So you exhibited very well, and we are very much thankful to you on behalf of Jyoti Vidyapeeth Women's University, as well as our partner institution, Asoka Institute of Technology and Management. That is your institute. We are
Yes, sir.
thankful to you, and we hope that we will see you again in future. Thanks once again. Thank you very much for your
Thank
very
you,
nice.
sir. Thank you. Thank you, everyone. Thank you, sir.
Thank you. Namaskar.
Okay.
Namaskar.
Namaskar.
Now this is
Con-
the
uh,
end of the session, and tomorrow, on as per the notification, we are going to start our third day workshop. Thank you, sir. Thank you.
okay. Thank you. Thank you, sir. Can I leave?
Yes, sir. Yes, sir.
Okay.
Please.
Okay. Thank you, sir. Thank you very much.